Most of us view our minds as a secure archive. We believe our childhood memories are locked away in a private vault, but that vault is actually made of fleshy, wet tissue. Your brain functions as biological hardware. It is a physical machine, subject to the same mechanical constraints as any other piece of technology. These aren't abstract thoughts, they are physical data. Every memory is stored in a neuronal activation pattern, a rigid, interconnected structure of neurons that fire in a specific sequence. This storage system functions like a computer hard drive. If you can isolate the file, you can target it, highlight it, and send it to the trash. Because human identity is built on these files, it acts as an unpatched server. It remains open to anyone capable of gaining administrative access. To find the levers of this system, we have to look at the architecture of the mammalian brain. Your brain works subconsciously, stitching together varied sensory inputs to create a cohesive experience of the world. This experience doesn't arise from a soul or free will. It is the result of shifting particles, governed by the laws of physics. Every cherished memory has a readable, material footprint. It is a physical arrangement of matter inside your skull. If identity is a mechanical output composed of particles, it suggests that human experience is a system that can be manipulated through physical means. Theoretical physicist Michio Kaku has documented a verified exploit on this biological system. Researchers conducted a neurobiological experiment targeting specific memories in living mice. By identifying the neuronal pattern tied to a learned task, scientists introduced a chemical compound. The targeted neural connections were dissolved. A lived experience was removed from the biological record by a chemical command. The mouse's behavior reverted to its pre-trained state. The deletion was successful. The brain lacks a biological firewall to prevent the chemical removal of its own history. Chemical deletion is a blunt instrument. The more complex application of this exploit is the ability to rewrite the data itself. Before deleting the memory, researchers recorded the exact neuronal pattern, translating the biological event into a digital format. This led to the download phase. Researchers used implanted electrodes to force that specific pattern back into the mouse's brain. The mouse recalled the complex task perfectly, despite having no natural memory of the training. This technology moves us toward the possibility of uploading fabricated memories or executing cross-creature data transfers. When a memory is an artificial download, there is no material distinction between a lived experience and an injected file. The threat isn't just an external hack. The system is currently failing from within. James Gleick describes human memory as a fluid storytelling mechanism rather than a static recording. Recalling an event is a destructive act. To access the data, the brain performs a reconstruction, altering the sequence and saving a new version over the original. Even without electrodes or chemicals, the mind is constantly corrupting its own archive. We are caught between two paradigms, Kaku's rigid, hackable data and Gleick's fluid, self-corrupting psychology. Whether the change is driven by a natural glitch or a laboratory hack, the human past lacks a fixed foundation. You are a biological machine running on code that is vulnerable to both internal decay and external editing. The memory you trust most could be a file you edited years ago or one that was downloaded yesterday. If you could delete a traumatic memory tonight, would you?